grain size, grain shape, and sorting. These are the three properties of clastic sedimentary rocks, and those three properties will be used to determine the name that we give each of our clastic sedimentary rocks. So I've pulled samples 53, 54, 62, and 63. These are the samples you're being asked to review for this lab activity. 53 and 54 are both sandstones, which means their sizes are within the sand range. So between 1/16 of a millimeter up to 2 millimeters per grain. That is what can be labeled as a sandstone. Now 53 is called Arcose. It's also known as an Arcose sandstone. That simply means that the grains are not made of quartz sand, but rather feldspar sand. That's why you see a little bit of a pink color to this sample, is because its sand grains are made of feldspar. If you take a close look with your magnifying glass, you may actually see some of those potassium feldspar-like qualities within the grains. Sandstone, number 54, is just your regular old quartz sandstone. So my sample is a finer grained sandstone. So we're closer to that 1/16 of a millimeter in diameter per grain compared to that Arcose. That Arcose was a little bit larger. But as long as we're within the 1/16 to 2 millimeter range, we are considered sand size. So here's an example of sandstone. So we've got, you can use your magnifying glass if you'd like to see closer into this particular sample. I don't know if that's going to show up. But in this particular sample, we can see a great deal of bedding. We also see a great deal of dog hair. So we've got some great bedding going on in this particular sample, and that is very indicative of the gravity-driven process of deposition for our sand. So the next sample here is conglomerate. Conglomerate is number 62 in your rock and mineral kit. And I don't know about your sample, but my sample was pretty lackluster, and it was not a great sample of conglomerate. So I hope that my extra samples here can be of help to you if your sample was as bad as mine. Now, conglomerate is just a poorly sorted clastic sedimentary rock where we have multiple sizes of grains within a sample. And those larger grains, in order to be labeled a conglomerate, those larger grains must be rounded in shape. So that is what makes the difference between a conglomerate and a breccia. A breccia, as you can see, we have multiple sized grains, but those big grains are angular in shape. And so that is what makes the difference between a conglomerate and a breccia. Now, in some cases, you may come across samples that, oh, there's some rounded grains in this poorly sorted rock, but we also see possibly some subangular grains. And so that is another reminder that our labels and our categories for all of our rocks and textures, they are not clear cut and neatly defined. Mother Nature works in a lot of gray areas, and we just try to place her into categories, and sometimes that just doesn't work. Now, finally, our final sample is shale. And again, my sample of shale, look how thin that is. So your sample of shale may be as paper thin as mine, but this is just a characteristic of shale. And when you break a sample, it has that property of fissility, F-I-S-S-I-L-I-T-Y. That simply means when you break it off with a hammer, It's going to break off on those nice, neat layers that it has. Now, this is a sample of shale, and you can see it is different from my sample from my kit. The sample from my kit was dark in color. It was probably more of a carbon-rich or organic shale. This shale is from the Grovant landslide in Wyoming, and it has a little bit different of a color. We have less organics mixed in with this shale, but we can still see those same properties. We have an extremely fine grain size, and we see that property of fissility, which is necessary to be called a shale. Otherwise, we would have to call this a claystone or a mudstone. And a good example of one of those would be this right here. You can see that we are lacking that fissility that we saw in the previous sample of shale. This is just a claystone or a mudstone. All right, so one of the tips that you can use a ruler. I like to make my own ruler, and so of course this is in centimeters. And so between each centimeter mark, I've placed a mark in the middle to indicate 5 millimeters or half a centimeter. And this is going to be helpful as you measure your grains in your rocks as necessary. You can use a clear ruler if you have a clear ruler. But this is just another tip to help you estimate the sizes of your grains within your rock and mineral samples.